Hey guys, I welcome you to the channel, which is Mathematical Engineering, Core Theory and its Applications. I'm providing you some of the concepts with the help of numericals, theorems, some of the graphical representations, so that we can actually come closer to the concept of understanding better what is all about the mathematical engineering in terms of mathematics, in terms of engineering, and in terms of physics. This video is all about two theorems, which is Rolle's theorem and a mean value theorem. I'm just going to discuss out the theory with the help of some graph, so that you can understand what's all about the two theorems, which help us to actually calculate further numericals as well. In the Rolle's theorem states that, which is obviously in the figure, in the next figure, states that if a function fx is continuous in the range which is given this a to c, is differentiable in the range a is less than x is less than c, and satisfy fa is equal to f of c, then for at least one point x is equal to b where a is less than b is less than c, f of dash b is equal to 0. This Rolle's theorem states that for a well-behaved, continuous and differentiable function that has the same value at 2 points, either there is at least one stationary point between those points, or a function is a constant between them. The validity of the theorem is immediately apparent from the figure, and a full analytical proof will not be given. The theorem is used in deriving the mean value theorem. This is the a less than x is less than c, and this is a point b in this range. So the graph of a function fx showing that if f is equal to a, then at one point at least between x is equal to a and x is equal to c, the graph has zero gradient. There it is showing the zero gradient, and now it's the mean value theorem. This is the graph of the mean value theorem. Yet again, let's see. The mean value theorem states that if a function f of x, which is this one, or f of x, this one, is continuous in the range, this is the continuous function in the range a to c, so including a to c as well, and differentiable in the range, and it is differentiable in the range between this and this, then f of differentiable at point b is f of c, this one, and f of a, this one. Okay, so f of c minus f of a, and that is divided by c minus a for at least one value b where a is less than b is less than c. Thus the mean value theorem states that for a well-behaved function, the gradient of the line joining 2 points on the curve, gradient of the line joining between joining 2 points on the curve, is equal to the slope of the tangent to the curve for at least one intervening point, that would be b. And the proof of the mean value theorem is found by examining the above figure. This is how you're going to find it out. Okay, at here it is had a zero gradient, and here you can actually represent it like this for at least one point b. Okay, so moving ahead as follows, the equation of line AC is this one. G of x is f of a plus x minus a, f of c minus f of a into c minus a, and hence the difference between the curve and the line is this one. The difference between the curve and the line, which is this one, is represented over here by h of x, and then you can see that it is f of x minus u of x, which is f of x minus f of a, which is x minus a, and this one is this one. Since the curve and the line intersect at a and c, h of x is equal to 0 at both of these points. Hence, by an application of Rolle's theorem, x is equal to 0 for at least one point P between A and C. Differentiating our expression for h of x, we find this one. We can find the differentiation of expression as well, which is h of x, and hence at B, where differentiated is equal to 0, we can find this one as well, which is the same as which we were derived initially, which is equal to this point. So how we reach this point, we have actually gone through some of the calculations, some of the expressions as well, so that you can reach at this point, which is the main purpose of the mean value theorem. Okay, just the having the intermediate point, and you can have the differentiation as well. Okay, so it's all about this, at which you can actually explain the differences between the curve and the line, and taking the derivative and approximating it to 0, replacing it by b, obviously then you have the same expression like this one, and taking the help from the Rolle's theorem as well. Okay, so obviously a Rolle's theorem, it has a 0 gradient, so obviously we will going to assume that this one is equal to 0. Okay, so at least at one point, so we can assume that we can have this one relationship as well, or the expression. So for details that you want to have it for, because these two theorems are interlinked, just for your point, just for the sake of understanding the differentiation, you need to know that what is all about the Rolle's theorems, or it is also the mean value theorem. It's all by Rolle's theorem means that you need, it's by the name of a scientist probably, but obviously you need to understand it as 0 gradient, and in other you need to get this expression, and just connecting the two theorems you can have the well-defined expressions and the well-defined theory as well. So I hope that this concept is well defined in front of you. If you have any queries, you can just mention in the comment section, and we can answer accordingly. But for this video, it's all about the Rolle's theorems and the mean value theorem. For the next video, till then, take care.